the blue marble. That was our first view of ourselves. We really are the blue planet. We're hanging out here in the middle of nowhere. In fact, Apollo imagery was part of the justification for putting together a satellite that would look at the Earth.
That satellite was the first Landsat. The Landsat mission now holds the title for the longest continuous space-based record of Earth's land in existence. At least one Landsat satellite has been orbiting the Earth since 1972. That's nearly 50 years of steadfast observation. The program was born in the midst of several historical flashpoints during a time when the world was changing quickly.
Well, it really was a perfect storm. We had a lot of technology coming out of World War II with air-flown sensors. We also had an awareness of the environment between Rachel Carson. Even Stewart Udall wrote a book called The Quiet Crisis. Those two things together, the space race, all of those came together.
But the Landsat story doesn't actually start with NASA. It starts with the United States Geological Survey.
There were a couple of really interesting players. The primary one is William T. Pecora, and he was director of the U.S. Geological Survey. His boss was Stewart Udall. He tried floating it around, and it didn't quite make it. Department of Defense, the CIA, NASA, which was just beginning at that point, they all said, nah, this isn't the right time. So in 1966, Pecora and Udall announced that, okay, fine, Department of Interior will launch. And so that caused a big kerfuffle, and the bottom line was that NASA was forced to step up and say, yeah, okay, we'll do it.
But let's pause for a second. Obviously, there was a big push to make an Earth-observing satellite. But what exactly did it need to do? Landsat's entire job is to collect light, visible light like this, and non-visible light like this. After Landsat captures the light it sees, it can make two kinds of pictures, true color images and false color images. Did you know your eyes can only detect red, green, and blue? It sounds crazy, but it's true. In fact, if you took a magnifying glass to the screen you're probably looking at right now, you'd see a jumble of red, green, and blue dots. Mix those colors together with different intensities, and your brain interprets all the colors of the rainbow. True color images are made by combining red, blue, and green light. But what's even more amazing? Landsat also captures infrared light beyond what we can see. And that light can reveal some incredible things when you look at a false color image. Like the difference between types of plants, how healthy those plants are, healthy coral reefs and even dead coral reefs, fire tracking, ocean pollution, the possibilities are nearly endless. In fact, I bet you've probably seen Landsat's influence on pop culture without even knowing it. From Google Earth and works of art, to television and movies. And I should know, before my untimely smushing by an 85-foot tall great ape deep into the film, I, your narrator, played Landsat Steve in Kong Skull Island. But I digress. Now, back to our story. NASA and USGS get to work, largely under the direction of lead engineer Virginia Norwood, who was often called the mother of Landsat. Norwood and her team had to design an experimental instrument, the multispectral scanner, that had never been flown in space before.
We took and NASA took a real gamble to propose a scanner for this, met with quite a bit of skepticism.
To assuage the skeptics and test the scanner's capabilities, the team loaded up the test model on a truck and headed to Yosemite.
And this was because nobody believes that scanner will work. I think you better give us some assurance.
The true test came when Landsat 1 launched on July 23, 1972. Sadly, William T. Pecora, one of the project's original champions, died just 3 days before Landsat took its place in orbit. But with this launch, the United States and soon the world would step into a new paradigm of Earth observation. Never-before-seen snapshot of land resources in the environment would be key for critical decision-making decades into the future.
It's impossible to predict really the exact lifetime of one of these birds, but we hope that the spacecraft can go on perhaps for another year, perhaps another 2 years, bringing down the data as it has been doing.